then I see that it's 7 and 3, so 7, 3, 10, 2, and this is the result I got. And then I will do the same, but when I will use Google, and I will use all the 4 variables. Yeah, it's actually faster. So thanks for the advice. So the first thing that I see that first that Google is moving positively with Apple. Okay, in the first regression, I see that the R score that I got is 15%, and the p-value, I actually see that the p-value is not really significant for Apple, but it's very close to be significant. It's like 0.09. Okay. For this guy, I see that I got a higher R square. By the way, one thing that it's missed the adjusted R square, but I guess it's okay for this class. And I see that Apple is not significant. GE is like far from being significant. It's like 0.9 p-value, it's huge. And the others are also not very significant. But this is the model, so let's use it as it is. Okay? Everything is clear about what we did. And again, as you saw, we use the training set to find the coefficients. If I will use the test set, I will get different coefficients. Okay, now I want to check my prediction. So I will run over the training set, and I will see what I would predict if I wouldn't know the return of Google. Okay? So let's write prediction 1, similar prediction 2. Prediction 1, so I will use a linear reg predict. And again, we know already how to use it. The first variable is the model. The second variable, remember, it's just Apple. Okay, so of course I will lock the model. Not log, linear predict. Use the model. And the second variable, use the return of the free space. So, force. Again, I will lock the models. And I will tell it. Okay, guys, I want you to be with me. So if not, tell me.
Can you show the prediction
formula? Yeah. I'm using linear reg predict because I want to predict. The first argument is the line of the coefficient,
right?
And I lock it. And the second argument is just the return of Apple, because the first model was just over Apple.
I get an error must have examples from both sets.
The what?
I get an error that says must have examples from both sets.
I have the same problem.
Why? When I try to do the log reg tree.
No, but
No, it's
linear reg.
Linear.
Ah, that's why.
Yeah, the problem is that probably it's a linear, different types of regression.
Why is it different?
Sorry?
Why do we use a different
Oh,
function?
Why we're using a different function? Again, the logarithmic trains, guys, The log train is only for 0 and 1 results. Here the results are not 0 and 1, they are numbers, they are percent. Any other question?
With the red train?
The linear rate. No, okay, so we have two different types of regressions.
Yeah.
There's the linear regression
Right.
for any type of result, and the log regression only for 0 or 1.
Oh, it's binary.
It's binary.
Yeah.
The result, the predict of the log regression will be a percentage, but the data that I run on should be 0 or 1. Okay. Guys, did you all get it? We still have a long way to go in this question.
Just give us a second. What's your why?
Ah.
Okay, let's continue. So let's start with looking at prediction 1. I want to find the root mean square error. So I will insert another column here, and I will write square error. The square error is like before, is the prediction minus the real. It doesn't matter the order because I square it. Square. Okay, and then I can do the same for prediction 2. I will have square error 1, square error 2. Okay, now we find the RMSE. Model 1, model 2, and like before, it will be square root, the average. Okay, any question about what I did?
Yeah, can you go to the formula for the square root 1?
Yeah.
So is it,
Why do you want to lock B17? Don't you want it to move with it down?
Oh, my mistake, yeah. I should lock only the B, not the 17. Totally right. And I will-
Wait, I'm not.
why are you not
Okay.
anything?
I'm looking because I wanted to, you don't need to do that, because I wanted to take it to here. Just copy it here.
And the two is square error two is what? Is he remember square error two formula? Kobe, can we see the square error two formula? Because it takes into account everything.
Sorry?
The formula for the square error two.
Yeah.
So it's prediction.
So I'm taking the
So it's
prediction
all
to
relative to the other thing.
the Google, to the real thing.
Yeah.
Okay? Let me check.
Oh.
Please, square.
Yeah.
So in other words, because the RMSE for the first one is bigger, the second one will use all four.
No, we get. I want first to do everyone. Guys, any question about it, or I can continue?
Can I see the square?
This one? It's like before. The square root of the average of this column.
Got
The
it.
square root of the average of this column. Okay? Any other questions, guys? Okay, let's continue. So what I see here is the RMSE of model 1 is higher than the RMSE of model 2. Okay? The next part, you don't need to do with me. I will just copy all the formulas and hopefully it will work. So I will use the same thing, I will just use it on the test set to see what the result will be now. I can actually copy including the table. Now let's see.
How do you just copy and paste and calculate everything again?
Um,
No special way to copy and paste.
No, it's not a special copy paste. Just if I load the right stuff, it will work. As you can see, it doesn't work perfectly. Try to understand what I did wrongly.
Because you locked one of the.
Yeah, Ah, okay. It just happened because the training set and the test set are not the same size. Okay, so I will need to change a little bit. Again, I don't. You can do it from scratch. This is 20, and this is maybe 19. Yeah, this is 19. So it's a little bit different because it's 19, but we need to change this formula a little bit. But this part is less important. It's exactly the same. I just want to do it fast so we can understand the result. So as you can see, actually, when I run on the train set, so on the test set, on the test set, I actually see that model 1 surprisingly is better than model 2. Okay, so my conclusion is that was some overfitting when I use 4 variables. Again, because it's a very small training set of 20 samples. It's not that overall 4 variables is good. 4 variables is good. Any questions about that? Yes.
So if we wanted to, just to understand what this question is asking, if we wanted to do it from scratch on the test set, would we do the linear predict using the coefficients from our training set models and then do the whole error RMSE thing, blah, blah, blah.
Okay. So the conclusion here again is that model 1 is better. Now the last question, can we use this model to develop a profitable trading strategy? So first I see that model 1 is better, so probably I will use model 1 and not model 2. Can it be profitable? I would say, based on this data, I would probably answer that the p-value is too high, it's not significant enough. We probably need more data. Another problem is that we focus the result of Google based on Apple on the same day. So it's not really helpful. Because when I know Apple, I know Google. If I will use, okay, Google based on Apple of the previous day, maybe it will make more sense. So overall, the answer is that this model is not so good for a lot of reasons. I think this is enough for, yeah, and there is only one question. So, any questions about overfitting? I don't expect you to see a whole question in the exam about overfitting. It will be like, I think, more of a one part just to analyze it theoretically, I think so.
Is he going to in that exam mix all these different concepts into one question?
Yeah, I think so. I think part of it. I think usually it's not hard to understand what thing you need to apply. So that you will need to guess, hey, should I use a log regression or KNN? It should be very clear. It will be very clear, hopefully. I don't think it's a problem. I think it's maybe sometimes like difference in differences, but I think they will say what you need to apply. In my exam when I did it, it was okay. Yeah.
Wait, just to clarify, so if we were to redo the thing for the test set, we use the linear right train data from the training set?
No, so for the test set or the train set?
Test set.
Test set. So the test set, I'm not using the linear train. I'm using only the predict. I already have the models.
Yes, before we used
The models were created using linear train.
Right.
They're already like created using the training set.
Like when we do the predictions for the test set, we use coefficients from the red tree models.
Definitely,
Right?
yeah. Let's only one, for example. So you can see the coefficient came from here. This coefficient. Right?
And then we know that model 1 is better because on the test set, MSC is lower on
Yeah.
model 1. And so,
I always test only on the test. The result on the training set, I wouldn't say they are meaningless, but they are less good of the test.
so every time, like when we're looking at which one is a better model, it's always on the test. The test set.
If I have a test, definitely it's better. Okay. Any other questions? Okay. Let's take 8 minutes of break. So, and come back fresh because we have a lot more interesting stuff.